Example 4 says describe how to transform the graph of f of x equals ln of x into the graph of the given function. Now be careful, notice it's the natural log of x, and this one is, if you look on A, it's log base 5 of x, right? So I'm going to have to do a change of base first, and then we're going to work on our transformation. So, change of base. I need to go to what base? I need to go to E because I want it to compare it to the natural log of x. So how can I rewrite this with base E?
Natural log x over natural log of x5.
Good. Just that change of base formula we just did, right? Before example 3. Now, this is a little odd because when we're doing transformations, remember we're looking at y equals a, since it's natural log, I'll use it, natural log of bx minus h plus k, right? There's no fraction in it, is there? But hold on. So, just as a side note here, if I just said I had x divided by 2, how can I write that without a fraction? What is the same thing as dividing by 2?
1/2.
Multiplying by 1/2, right? So I could have wrote that as 1/2 x. So instead of dividing by the natural log of 5, I could write this as 1 over the natural log of 5 times the natural log of x. Hold on, guys. All right, so we've got this 1 over the natural log of 5 times the natural log of x. So let me just rewrite this real quick. So this is g of x equals, so what is that 1 over natural log of 5? Is that my a, my b, my h, or my k in my transformation? What's being multiplied times the natural log of x? Is that the a, the b, the h, or the k that's being multiplied times the log? The a. So my a is 1 over the natural log of 5. So a is approximately what number? How can I find that? I can put it in my calculator, right? 1 divided by natural log of 5 equals, approximately 0.621. So what is that for my graph? Is that horizontal or vertical? It's vertical because it's not inside with the x. Is it a stretch compression or is it a shift? Stretch or compression because it's being multiplied. So if it's being multiplied by 0.621, is that a stretch or a compression?
Compression.
It's a compression. All right. So, just think about it. You got your parent function here. Let me choose a different color for the parent function. Remember, you have two things going on. I think some of y'all came in and I showed you this. So you have a vertical asymptote at x equals 0, right? And you have that ordered pair 1, 0. Is that vertical compression going to affect your x or your y? Vertical compression, does it affect x or y? Is it inside with the x? No, so it doesn't affect the x, so it has to affect the y. And so what are we going to do to our y's? Do we add, subtract, multiply, or divide by that 0.621? It says a times log, doesn't it? So you're going to multiply by, technically it's the 1 over natural log of 5, but I'll let you get by with the 0.621. So does that change your vertical asymptote? Remember your vertical asymptote was x equals 0. There's no y there, is there? And is it going to change the point? Y'all with me? This a Monday? So I would take my y values and multiply by 0.621. It doesn't actually change it, does it? So I know I'm still going to have that x-intercept in the same place. I'm still going to have the vertical asymptote in the same place. But if I vertically squish that graph, compress it, what's going to happen to it? Think about it. Take your hands. Pretend you got a balloon in between them, vertically above each other, one above the other. If you have a balloon and you squish it, what's going to happen? It's going to get wider, isn't it? So my graph is going to get a little wider here. It's not as steep.